again. This is Wi-Fi Tech Lab channel. Of course, we are back again with that video continuation of device security, VLANs configuration, DHCP, and the DNS. If you pay attention, we still have the same lab configuration that we were doing last time when we uploaded this video. If you still remember what was going on this lab, whenever we were trying to ping from each domain, as you can see, we have different VLAN IDs here. We have VLAN 10, we have VLAN 20, we have VLAN 30, we have VLAN 40. Whenever we try to ping from this broadcasting domain to this broadcasting domain, we were getting timeout. Okay, let's verify that. I'll just come in here and then I will try to obtain the configuration of the network interface card. In this case, we have .2 as our IP address. Let's see what is the IP address. We can try to send the ICMP code request to. Okay, this is .34. It's sitting on VLAN 20. Let's try to ping it using a command prompt. Okay, all we have to do is type in ping 192.168.10.34. Remember, we are expecting to get the timeout because there is no routing protocol that is configured on this lab. Okay, well, when we're talking about the routing protocol, I am still gonna be releasing the separate explanation based on each routing protocol that we use in the networking industry, but I'll just touch up with some few concepts that we may need on an interfaces that are directly connected. We have something called the administrative distance of the directly connected interface. It's 0. Okay, and then we have the routing protocols that we use. Like I said on the previous video, we have the static route, we have the default route, we have the dynamic route. Okay, in this case of this video, we will be using one of the dynamic routing protocols. We will use something called the OSPF. Okay, open the shortest path first routing protocol, OSPF. Okay, this routing protocol, it uses something called Diksha's algorithm to calculate the route. All right, it have the administrative distance of 110, and then there are other routing protocols that fall under dynamic routing protocols such as RIP, which stand for routing information protocol. And then we have something called BGP, and then we also have something called EIGRP. We have also something called ISIS. Okay, ISIS. Okay, and then what we are trying to do now, we're trying to link these distribution layers to the core layer switches, sorry, in the core layer routers. Okay, we're trying to make this to be our backbone. In this case, we will use area 0. Okay, so maybe let me just come here and create some small lab. I'll just place 4 routers. All right, or maybe let me place it here. Okay, and then I will try to link these routers together. I will have the link. Okay, let me just remove that. Let me use this serial DTE and DCE cable. Okay, sorry about that. Okay, maybe the routers that I'm using currently, they don't support the serial, so I may need to add the interfaces. Let me just select another router that will be able to support the serial cable. Okay, I want to demonstrate some of the routing protocols and how it actually works before I actually come to configure these two routers that we have. Okay, let's just use this one for now for demonstration purposes. I'm just gonna select another one and place it somewhere around here. Let me use 4 for now, and then I'll go back to select the cable type that I want to use, and then all I have to do is to connect it to, okay, let's use the serial 2/0, and then same thing applies in here. Let me press auto so that I will just connect on any available port on the router. Okay, so suppose we have your computer somewhere around here. Okay, this could be a branch. Maybe let's say this is branch 1 or branch A, and then this could be somewhere maybe a branch, let's say maybe branch B. This could be a branch C, or maybe this could be your head office. All right, somewhere here. All right, so what we're trying to achieve in here, we're trying to allow the local area network or the private IP addresses on this gateway from the private IP addresses that tapping out from this gateway to outside. Okay, they will need something called the routing protocol to be able to send some packet out from this router. Okay, so in order for this router to send something out to whichever router that the packet is trying to send towards that destination, this router needs to exactly know the routing information towards that destination. Okay, so these two routers, they need to exchange something called routing information or the routing tables, because each router has its own routing table. Okay, for instance, let's touch upon the OSPF. This is again a dynamic routing protocol that is used to send the packet from one router to another. Okay, so again, we have said that the OSPF routing protocol uses areas, okay, and also it uses Dichtars algorithm to calculate which path must be taken to forward that traffic. All right, so what determines that is the bandwidth. All right, so, and then we also talked about the RIP. The RIP uses the number of hops on its way. Right, it uses the number of hops on its way. The lesser the number of hops on its way or on its path, that is the preferable or that is the most used routing path to forward the traffic towards the destination. Okay. For instance, as you see here, we have equal number of hops. This is the first hop, and then we have the second hop over here. And also here from this router, this is the first hop over here, and this is the second hop over here. So we have total number of hops. Suppose we have something called or maybe we have another router sitting somewhere over here. All right, now which means we have one hop, we have two hops, we have three hops. Let's say this was the head office. Okay, maybe let me just do this. Let me put it over here. So in order for these routers to send information towards the head office, this would be preferred routing. Okay, because this router or this route have multiple number of hops. So we have the first one here, we have the second one here, we have the third one here, and then we have the last hop here. All right, so the routing information relies on the number of hops. And then we have something called the path vector, BGP. For the fact that you can be able to see or view this video, it is because of the BGP routing protocol. All right, now we're gonna be making a video based on each topic about the dynamic routing protocol. For now, let's go back and try to make this lab to work. I'm just gonna try to connect this router. I'll just use any cable. Or maybe let me just replace these routers, or maybe let me just add some interfaces on them. I'm trying to look for, or let's just use this one. Okay. Okay, the router is on. I will have to switch it off. Let's add this module. Or the module is not compatible. Let's look for serial. Oh, there we are. Okay, now let's switch it back on. The router is booting up. Let's come to this one and do the same thing. What I'm trying to do is I'm trying to add some serial modules on this router so that we'll be able to configure the routing protocol on these routers. Okay. I have switched the routers back on. All I need to do now, I have to select my cable in here. This is auto, and then I'll just do this. Okay, and then I will add another router. Let me just take this one over here. Okay, now let's do the same thing on this one. All right. So because this is just for a lab, a simple lab, this is actually not preferable, because this simply means this is a single point of failure. If these routers go down, then we have the problem about the internet. This is just for demonstration purposes. As we move along, we will implement the redundant solutions to our lab configuration. All right. So what we're trying to do, actually, again, we are trying to make sure that now that these devices have managed to obtain the dynamic IP addresses, they need to also be able to communicate and also break out to the internet. All right. They need to be able to ping this router. They need to be able to ping that router. They need to be able to ping that router over there. With the help of an OSPF, we're gonna be able to do that. Okay, now let's begin our configuration. We're gonna start on this router over here. All we have to do is to navigate to the CLI, and then we have to enable the router as normally, and then we have to navigate to the global config mode. All right, by tapping in the command config T. And then let me try to show this router so that everyone will be able to see what we're trying to configure. As you can see, this router have multiple interfaces that are connected to it. But if you look closer, there is none of them that are currently on or up. If I run the command do show IP interface brief, I'll be able to see that most of these interfaces, they are just down, administratively down. Okay. All we are trying to do is to hook them up and then being able to configure them. How do we do that? Again, we need to select the interface that we're trying to configure, and then we can deal with that interface and assign the IP address on it as usually. Okay, for instance, let's start by doing the configuration for fast Ethernet 0/0. I will select the interface fast Ethernet 0/0, and then I will just say no shutdown. Okay, as you can see, the status went green. It's also changed in here to up. Okay, the status changed to up in here. All right, because I have switched the interface up by the command no shut down or no shut. All right, now I have to go back to the interface and give it an IP address. I would like to give this an IP address that I will advertise to an OSPF. All right, that IP address could be or maybe let me just define an IP address that each of these point-to-point interface can use. Let me just say these will be using a /30 subnet, so let's give them 20.20.20.0/30, and then I will use another maybe 20.20.20.4. These are the network ID. These are not IP addresses. These are not usable IP addresses, but they are network ID. Okay. And then let's use 20.20.20.8/30. And then maybe here we can use 30.30.30.0/24. Sorry, /30. And then over here, let's use 30.30.30.4/30. Okay, I'm just gonna try to give this a color so that okay, let me select another one. We will be able to actually see what we're doing. Okay, now let's do it on this one as well. Let's do it on this one as well. Okay, So what is left to do now? Remember, we are trying to configure the IP addresses on these interfaces. We have selected our interface. All we need to do now is to type in the command 30.30.30.30, and then I can use only two available IP address on that subnet. In this case, I can use 1 or 2. All right, 1, it's either 1 or 2. 3, I can never be able to use 3 because this is the broadcasting IP address of this network ID. I can never be able to use this IP address. All right, and then 4, I can never be able to use this IP address either, as a result that it belongs to a network ID. All right, so there is only 2 available IP address on the subnet. It's either 1 or 2. For this gateway or for this interface, I will just use .1, and then I'll specify the subnet mask that matches the subnet, which is 255.255.252. all right, and then I will just label it logically by typing in description, and then I will give it my name, which I will call it description link to multi-layer switch 1. If you still remember, we have named this to switch 1. Okay, and then I will just save this, do copy run start, or let me just say do write. Okay, the configuration have been saved. Now let's deal with the other interface as well, which is interface fast ethernet 01/0. All I have to do is the same thing, IP add 30.30.30.5. There are 2 usable IP address in this network range. Again, there is 5 and 6. I can never be able to use 7 because 7 is the broadcasting IP address, and also I can never be able to use 8 because 8 is another network ID for another subnet. Okay, let's just use 5 in this case. And then I forgot something, which is 255.255.255.252. This is the subnet mask. Okay, I can also say description link to multi-layer 2 or multi-layer underscore switch 2. Right, do right. No shut down. This is very important. The interface must be up. Now let's go back to these serial cables. Right, so if you pay attention, this is the logical naming of this serial port. It's 2/0. So all I have to do is to come here and then select the interface serial or SE 2/0. Now I'm on the interface. If I say no shut, I'll be able to see which one is coming up. The reason why it's saying down is because on the other interface it is down, so it can never be up completely because on the other interface it's still down. So I will have to go to that interface and run the same command so that the entire status of this directly connected interface will go up as well. Okay, so now that we have typed the command no shutdown, we need to give it an IP address. We already know the IP address is 20.20.20. This is the network ID. So the following IP address that we can use is 9 or 10. I can never be able to use 11 because 11 is the broadcasting IP address of that network ID. And also I can never be able to use 12 because 12 is the network ID of the up following network ID. So in this case, I'll just use 9, and then I'll continue to use 255.255.255.252, and then I'll type the command again, description link R2, or let me just name it. Let's just say I'll just call it an ISP. Okay, link ISP to link ISP to, I'll just say R1. Okay, I'll just give this one R1. All right. Or we can just say maybe this is ISP2, ISP1, let's call this ISP1, and then let's call this ISP2. This is just for demonstration purposes, and maybe we can suppose that this is R1. This is the router on the side. Okay, so let's come back to this one, and then we change this description and then say R1 to ISP1. Okay, do right. We have successfully configured that interface as well. Now let's configure this one. Remember, we're just giving the IP address for now. We haven't started to create the OSPF instance, so we still have to come to that, and then also advertise our network IDs to those OSPFs. All right, so what we have to do now is we have to select the interface SE3/0, and then I will say no shutdown so that I won't forget, and then I can start giving the IP address to this serial 3/0. If I pay attention on this side, this is the network ID that I'll be using and that guides me. So I'll come and say 20.20.20.5, and then 245.245.245.252. Description link. It's R1 to ISP2. Okay, do right. Now all we have to do is we need to come to these routers for the ISP side. Remember, by nature you're not supposed to touch a router that belongs to, they usually call it the CPE routers. You don't touch those because they belong to a particular ISP, unless if you're working for an ISP. Remember, the network engineer, they work for ISPs. Okay, so let's say you're configuring the router for the ISP. All you have to do is you have to select the interface again, but you need to be sure which interface you're trying to assign the IP address to. In this case, this is the interface I can see, so I'll just say config terminal, and then I'll select the interface serial 0/1/0. Okay, no shutdown. Now after I click enter, you'll see that this status will go green. Okay, the interface is not up yet. Let's see why is that. Okay, let's go back to the other one, interface serial 0. I think we've selected the wrong one. Interface 0/1.1. Let's say no shuts down. Okay, so basically this is the interface for here. In this case, let's come up and say IP add 20. Okay, IP add 20.20.20.10. Remember, on the other interface we have configured .9. So 255.255.255.252. and then I can just say description, link this to link, let's say link ISP1 to R1. Okay, and then to also verify that this is actually directly connected to this interface which we have gave the IP address of .9, let's run a command called cdp neighbor. Do show cdp neighbor. I'll just write it in short and then type enter. This is gonna tell me exactly the neighbor of that router that I'm running the command on. So it says that the serial 0111 is directly connected to serial 202/0. Right. And then if I go to the router, I want to be able to see if this is actually have 20.20.20.9, the serial 2/0. So if I come here and then do show interface serial 2/0, let's see what is the interface is gonna tell me. It says that okay, the interface is actually up, okay, and it's directly connected. This is the hardware, and then this is the description link, and then this is exactly what's the IP address that we've been expecting. Okay, this is what we wanted to see for now, and then we will come to all of these information that you see. Let's go back to this router over here. So we are now trying to configure the other interface. Interface serial 0/1/0. We know for sure that this is the IP address, or this is the network ID that will be guiding us. In this case, I'll just say IP add 20.20.20.1. I'll just give it a .1, 245.255.255.252. No shard, we already run this command. I can now run the command link, and then this is just ISP1 to ISP2. Okay, I need to do right. I've saved all of this configuration, and then now this is the last router that we will be configuring. So let's just do this. Come to the CLI, and then we don't need no dialog. That's why I'm pressing no. And then I need to enable the router. Now I'm on the privilege config mode. Let me navigate to global config mode by typing in config terminal. All that I need to do now, I have to do the same thing that I've been doing all along on these routers. So I have to select the interface again, but I need to make sure which interface is actually encapsulating this traffic towards that interface. So I will have to try to verify that by typing the command. I will select the interface and then select no shutdown, typing the command no shutdown. Let's start by the interface SE0/1/1, and then I'll type in no shutdown. This tells me that this interface belongs to that network ID. I can just come here and say IP add. I can just say IP add 20.20.20.6. No shards. Sorry. 255.255.255.252. Description link from ISP2 up to R1. Do right. Do show IP interface brief. Now I want to see the IP addresses that we have currently assigned on this router. We only have one, because the other interface, the status is still down. So we only have this one that we have just assigned now. Okay, now let's select the other interface and do the same thing, which is interface 0/1/0. Okay, now I need to give an IP address, or maybe let me just say no shut, so that we'll be able to see the status come green. No shut. Okay, let's see what is going on. The interface didn't go up, so we need to come here and then type in a command, do show IP interface brief. This interface is the one that is down, so it's serial. This is the one. Okay, I'm just gonna copy and paste this here, and then select the interface and paste it over here, and then say no shut. We expect to see that this status becomes green. Okay, let's say do show IP interface brief. Both of these interfaces, okay, they are still down. So this one is still down, and then the other one is also down. We're just gonna find out now what is the issue behind it. Why are these interfaces, they are still down? Okay, now let's come in here. Interface do show IP interface brief. We're trying to check what is the issue behind. Okay, so this is the interface that belongs to this one. Now what about that interface over there, which is serial 0/1/0? Okay, let's try to select that interface. Interface serial 0/1/0. Let me just say do show interface serial 0. These are the steps now to troubleshoot the interface if the interface is giving you a problem, just like that. So you will need to be able to see and find out the issue. As you can see, this is currently disabled by the administrator. Okay, so we need to enable this by typing in the command interface SE0/1/0 and then no shut. Now the interface have went up. If I come here and select the interface or run the command do show interface SE0/1/0, I'll be able to see now that the interface is directly connected to another interface. Okay, now if we go back, we can see that there is no red sign, there is green signs also. Okay, now let's give it an IP address. Let's not forget that interface SE0/1/0, IP at 20.20.20.2 in this case, 255.255.255.252. This is the subnet mask of /30 subnet. Okay, do right. We have successfully configured the interfaces or the IP addresses on the interface where we would be advertising some OSPF. Okay, so what is next now? I want to show you something. Remember when I said that this routing concept start from the interfaces that are directly connected. The traffic is routed from one device to another device based on the status, whether is it connected or not connected. All right, so we're using routing protocols to interconnect the links. Okay, now let's do this. For instance, I want to ping the interface that there is, or the IP address on this interface. All right, so I want to ping 20.20.20.1. As you can see, this tells me that this is the first ping of 20%, this is the second ping of 20%, this is 40%, and this one is 60%, this is 80%, and this is 100%. All right, so it means the ping went successfully, 100% successfully. Okay, so from this interface I can ping the link, or I can ping the interface of the directed connected interfaces. So the other side of the interface facing on the directly connected interfaces. I'm not sure if that makes sense. So what I'm trying to say, from this interface, if I want to ping something on that interface, I'll be able to ping because they are directly connected. The administrative distance is just 0. Okay, it's just 0. Now, if there was a static IP, the static routing that was configured to reach R1 from the ISP2 to R1, that is considered considered as the administrative distance of 1. Okay, right. So how do we configure the static IP address? All we need to know is we need to know the network ID of the peer router, or of the router that we're trying to connect to. All right, we will need to know the subnet mask of that router that we're trying to connect to. Okay, in that case, if we're trying to connect to 20.20.20.8 network, I will use 20.20.20.8 network with the subnet mask of 255.255.255.252, and then I will have to specify the next hop. Okay, from where I am running the configuration from. So from here, where's the next hop? This is the next hop. This is the gateway of the next hop. So I'll be using this interface to get through here. That would give me the static IP address. The static routing. Okay. So we are using the dynamic routing protocol selectively, and we have chose to use OSPF, open the shortest path first. All right. So let me just do this. So that everyone will be able to see that this is actually an OSPF. Okay, now remember what we said. We have said that these access layer switches, they are belonging to layer 2, right? These are the layer 2 switches, and then we have layer 3 switches. What is the difference between the two? These switches, they are capable of doing more enhanced features more than what the layer 2 can do. In this case, this one, they are capable of doing routing. They are capable of understanding what is called layer 3. They understand the packets. All right. So in this case, we can be able to configure this interface so that we can assign the IP address on it. As you can see, this is gigabit 1/0/5. This is the interface that we would be giving the IP address that belongs to this network ID. All right. By default, these switches, they need to be enabled. So they will need to be enabled so that they will be able to configure with layer 3. Okay. So let me just say do show IP interface brief to see all of the interfaces on this. So remember, we have said that we're willing to use 5. This is 5, which is directly connected to fastnet 01. Fastnet 00. I'll run the command do show CDP neighbor so that I would be able to see do show CDP neighbor. Okay, what I'm looking for is fastnet 00. This is the one on the other end, and then this is the interface that I'm willing to configure. So all I have to do is select the interface gigabit 0, sorry, it's actually 1/0/5. all right, remember what I said. I have said that the interface is actually up. However, I cannot be able to assign it an IP address. Let me do an example. IP at 30.30.30.1.255.255.255.252. What does it say? It says invalid input detected, because the same thing that I can be trying to do in here, let me say enable config. Okay, so let me just say Wi-Fi tag or the password. Okay, let's just come in here and then go to any interface here and then bypass that. So if I can try to select, maybe to show, let me just say select interface FA 0/24 and then try to give it an IP address 30. I'll just select any IP address 255.255.255.252. I will get the same invalid error message, because now I'm trying to make this layer 2 to do something that it cannot do. It's not capable of understanding these IPv4 addresses or IPv6. It doesn't understand layer 3. So on this switch, currently the current state of this switch is the same as layer 2 until I run some other command which says no switch port. All right, this command enables us to do the configuration of layer 3 on the switch. All right, so now if I type in IP at 30.30.30.1 255.255.255.252, it will be able to go in. Why? Because now this interface is ready to do the task that routers can do. All right, now let's do this command description link to R1, empty layer 1, multi-layer 1 to R1. Okay, the interface is already up. There is no need for me to configure some sort of no shutdown. All right, I have successfully configured this interface with an IP address 30.1. Now let's move on to this one and do the same thing again. Enable config terminal. I'll come in here and then I will type in the command interface gig 0, or it's actually 1/0/5, no switch port. Right, so this is no longer a switch port. We're giving it an IP address of 30.30.30.5 255.255.255.252. I won't type in the command no shutdown because the status is already up. Do show IP interface brief to see the status of these interfaces on this multi-layer switch 2. I'll be able to see that this is up and also this is up. This is the IP address that we have configured. All right. And then I can be able to see fastnet01 by typing the command do show CDP. Do show CDP. This is a Cisco proprietary discovery tool that we use. So CDP. Okay. So do show CDP neighbors. Okay. This is telling me that this interface is the interface that is on this other side of the cable. All right. And this is where I am, but I'm trying to see what is on the other side, which is fast Ethernet 0. Sorry, it's fast Ethernet 1/0, which is this one. We have already configured the IP address on this, which is which is actually need to check here because I might have made a mistake on this one too. So let me just come in here and double check. I think I have made a mistake. Okay, let's do this. Config terminal, do show IP interface brief. So on fastnet01 we are seeing 5, so which means here we must make it 6. All I have to do is I must give it an IP address of 30. Let me see again that command to show IP interface brief. So I have assigned, let me see if I have, okay, so I have to remove this now because it's actually wrong. So I must just come in here and say interface no IP at 30.30.30.30 dot, sorry, it's .5 255.255.255. Now that we have removed, if I run the command again to show IP interface brief, I'll be able to see that now we have successfully removed that IP address that was recently assigned on that interface. So the IP address that we're willing to give is this one, IP at 30.30.30.6. This is the second usable IP address on that network range of the network ID 30.30.30.4. Okay. Now remember, we still need to type in the subnet mask of 255.255.255.252. Okay. Now do show interface gig 1/0/5. So this is directly connected interface, which is up, and then this is the MAC address of that interface. We can also see that this is the MTU size that is used. It's a default MTU size. So let's come in here. Okay, right, so we have successfully configured this interface. If we can try to ping this interface from here, because they are directly connected to each other, they must be able to ping each other without no manually configured routing protocol. Okay, so we just need to do a ping. I'm running a do command. For instance, if you're on a config mode, you need to run the do command. Okay, just like sudo if you're familiar with Kali or if you're familiar with any Linux distribution. So we just write do ping and then let's specify the IP address that we're trying to ping instead of .30.30.1. Okay. The reason why we're getting a timeout It's because this is the IP address of the multi-layer on the other side. Right, this is the IP address on this side. So currently we cannot be able to ping across. But what we are trying to do is we're trying to ping the IP address that is here, which is .5. Okay, I did this ping so that we will be able to see the difference once there is a configured routing protocol, which is OSPF, and then there will be an adjacency, there will be the neighborhood that will be formed among all of these devices as part of the same area. Okay, so if I do ping, I'll just say do ping 5. You will notice the difference now. We will have 5 of 5, and you will see that we will have some other outcome. Okay, let's do that now. As you can see, the first one was dropped. If I run it again, you will see that all of them will be successful. All right, as you can see now, we have all of the packets sent and received. All right, I can be able to ping from this device, from that particular interface, from this device to that device, but I cannot further ping whatever is in this interface or on that interface. Okay, so how do we solve that problem now? We're trying to make everything to communicate with each other, which is why we have brought something called the OSPF. But why do we use a dynamic routing protocol? Well, this is dynamic, so which means we don't need to manually go to update each and every router if there is the change on the network. For instance, if we were to choose any of these devices, now suppose that we are trying to change the IP address from the DHCP so that these client devices, they must obtain the IP address of the different network segment. Or maybe we're trying to change this into .11.66 or maybe .11 something else. It would be easy to configure all of this configuration on the DHCP, right? We won't have a need to go through each and every client PCs to manually configure the changes on all of these devices. However, because we're using a dynamic host configuration protocol, all of these devices will automatically learn that now this is the pool that I'm pulling from. This is the IP address that the DHCP is giving. Okay. Same thing applies on. Okay. So, as we are saying, if I were to use a static routing, I would have to go to each and every devices and give the route towards that destination, and also I was gonna come to this and point it again to this destination, and also I was gonna manually configure another static route from here, point it to this network, and then I was gonna actually manually configure all of these network segments that belongs to all of these VLAN manually. Okay, so the reason why using OSPF, we're trying to avoid it so that we can just configure and advertise all of these network IDs once and for all. If there is any changes into the network, the OSPF will choose the different routes towards that destination. Okay, we won't need to manually go and configure the routing protocol statically. Okay, so now let's do the configuration. Let's start from the ISP side. Enable config terminal. What we need to do here, let me just say ISP1. We need to enable the OSPF instance, which is we're gonna choose this number here. It could be from 1 up to 65,535. These are the process IDs or the instance that we can use. Preferable on my choice, I want to use OSPF10. Another thing that we're willing to configure here, we need to configure something called the router ID. Okay, and also if we check the router ID, it could be an IP address of this format. Alright, suppose I didn't configure the router ID on this interface. The OSPF will always will look for the IP address on the interfaces that it can use, which is something that we don't want, which is why we need to configure this router ID. In this case, I'm just going to use 1.1.1.1. Okay, and then all I have to do is I have to include the IP addresses or the network IDs of these interfaces that are directly connected to this router here. Okay, so I'm trying to enable the OSPF on these interfaces. Alright, so how do I do that now? I need to type in the network ID 20.20. I'm starting with this one, 20.20.0. As you can see, this is 0. Now, because this is an OSPF, we're not going to be using the subnet mask to further advertise this network. However, we're going to be using something called wild mask. Okay, wildcard mask. Okay, wildcard mask. What we're trying to do is we're trying to flip things around. So we're gonna start by the first octet. To work this out, you start by the first octet minus 255 from the first octet of the original subnet mask. In this case, it was 255, so I'll minus 255, and then I will have the 0 for the first octet. What about the other one? I will minus 255 minus 255, and then I will have 0 for the second octet of the subnet mask of this network ID. On the third octet, I will do the same thing, and then I will have 0. What about the last octet? If you pay attention, in all of our configuration, for instance, if I come to this router over here and then enable config terminal, do show interface, and then I will be able to see the information of all of the interfaces on that router. Okay, maybe to do this, let's do this. Do show run. Do show run. Okay, I'm typing it wrong. Do show run. Okay, now we trying to come to this one. Remember, this is the first octet, this is the second octet, this is the third octet, and then this is the last octet. Okay, why I'm saying these are the octets? Octet simple means it's 8 bits. Octet is made up of 8 bits, so there is 8 bits that makes up this octet. the last octet, according to what we see, we have 252. So in order for us to figure out the wildcard mask of that last octet, we need to minus 255252. In this case, there is 3, so we're gonna be getting 3. So which means the wildcard mask of this network is gonna be 3. Now I want to specify that this network ID will be participating on area 0, okay, because this is the backbone. So in order for us to form the OSPF membership amongst the routers, there must be always an area 0, the backbone. This is our backbone, okay. Now I will further advertise another network on this interface, which is 20.20.20.8, and then because they are sharing the same subnet, so they're sharing the same subnet, even though they are not on the same subnet, but they're using /30, both of them. So I'll just say this is 8, and then it also part of area 0, okay, area 0, do right, okay. Another way to configure this, you select the interface, let's say interface gigabit. Let's see which interface is there. It's serial. Let's see interface serial 0/1/1, and then from here we can just simply say IPv4 or IPOSPF, and we give it an instant, and then we just say area 0. This is another way that is nowadays used to configure or to make sure that that interface is part of that OSPF of this instance and also of this area, okay. We are done with that router OSPF configuration. Now let's move on to this one. Because this is the neighbor of the router enabled OSPF, we expect to see the adjacent forming as soon as we configure the OSPF on this router as well, which is ISP2, okay. And usually I'm just gonna usually two ISP, they are not connected to each other, but let's suppose that they are, okay. So this is just a simple lab to make you understand how to configure the OSPF. Now that we are on the router, let's configure the host name, and then we say ISP2, and then let's select the routing protocol that we're going to be using, which is OSPF. Let's use the same instance. Remember, we need to make sure that the router ID is configured. In this case, let's use 1.2, and then let's introduce or advertise our network that are running on all of these interfaces that are directly connected to this ISP router, ISP2 router. Now you will notice that as soon as I press enter, there will be a message coming telling me that I can be able to see the neighbor. This ISP1 is my neighbor, OSPF neighbor. I'll run the command to, okay, now let's see what's gonna happen. As you can see, there is a full, and this is an adjacency forming. This is the neighborhood forming between two routers. Okay, this is the network ID of the other router. This is the router ID, sorry, this is the router ID of the other router, which is ISP1. So if I come to this router here, ISP2, and try to see the neighbor that I have, I will run the command do show IP OSPF neighbor. Okay, this is what I'll be able to see. These are the dead timers. By default there is 40, and then we have hello timers. By default it's 10. Okay, so each and every 10 seconds the OSPF send those link state advertisement to discover, or it's hello timers to discover if the link is still available. Okay, so we have this neighborhood which is on OSPF instance 10 on our router ISP2, ISP1, sorry. Okay, now let's do the same thing on this one. How we're gonna do that? We're gonna go back to OSPF 10, and then we have to specify the network ID. In this case we're using 4. I will come here and change this into 4. There will be no adjacency forming because we haven't configured any OSPF on this router here. So let's save this configuration for now. Let's come to this router over here and do the same thing. Enable config terminal, host name, let's give it R1. Okay, now all we have to do is we need to create the OSPF instance also in this router by typing the command router OSPF 10, and then we need to specify the router ID. Let's give it 1.1.1.3, and then let's advertise our network, and then we will see the adjacency forming. It's either we start by this one or either this one. So we're still gonna see the adjacency because we have enabled the OSPF instance on these routers. Okay, so we have to type in the command 20.20.20.4. remember we're using the wildcard mask. I'll just say 0.0.0.3 area 0. Let's see what's gonna happen. We will see the adjacency forming between this interface. Okay, now as we can see, OSPF, this is 780 level 5, and then we have process, which is 10. This is the instance, and then we have this this is actually the router ID of the neighbor, which means this is the router ID of this neighbor. The neighbor for this R1 is that one. Okay, for now, because it only knows about this one. These are exchanging routing information. Okay, now let's run the command to show IP OSPF neighbors. Okay, as you can see, this is what we see. Right, this is what we see. If I run it again, this is what I will see. Okay, now let's go to this one. Let's go to this network now. So all we have to do is we're doing the same thing. We type in network, and then we specify 20.20.20.8, and then the wildcard mask is going to be the same area 0. And then let's wait and see the neighbor adjacency forming. As you can see, we have adjacency that is formed. So now all of these routers, they can be able to communicate to each other. I can ping whatever that is in here, I can ping whatever that is in there. To prove that, let's take any IP address that is configured on this router. I'll type in the command do show IP interface brief. I can ping any of these two. Let me just take this one for instance. This interface is located on the upper part, so this is the interface that I'm trying to ping from this router over here. Do ping 20.20.20.2. As you can see, we have successfully pinged that router from here. Okay, even though it looks like they are directly connected, but they are really not, because this interface is directly connected with that interface but not with the other interface. This is a different gateway and this is a different, so I'm trying to ping that one over there. If I can run the command do show IP route, I would be able to see the routing table of these routes. Okay, so the gateway of the last result is not set. This tells me that we are using the OSPF, and all of these, they are directly connected to each other. Okay, right, so the longest prefix match always win. Now let's go to this one over here. We will try to ping, and then you will see the difference that it won't be able to ping successfully because we have not enabled, or we have not created any OSPF instance on this multi-layer switch, layer 3 switch. Okay, now let's do ping. We're gonna try to ping the same interface, which is 20.20.20.2. As you can see, we are sending the first 20, it's failing, 20% of the packets it's failing, and now it's 100% of the packets it's failed. Right, so 0% was delivered. Okay, because this switch have no idea of how to get to that switch, to that router. Right, it doesn't have no idea of how to get there. So what we're trying to do is we're trying to make it knowledgeable of how to get there using the routing protocol, the dynamic routing protocol. So all I have to do is I have to say IP routing. This is the command that will help us to enable the routing from this multi-layer switch, layer 3 switch. I will have to specify IP routing first so that I will be able to further configure the instance. OSPF 10 router ID, let's make it 2.2.2.2. okay, and then we need to firstly advertise this 30.30.30.0 with the wildcard mask of 0.0.0. Remember, there are two configurations that touch upon the wildcard mask. It's access list and also the OSPF. Okay, and then other dynamic routing protocol like EIGRP, they don't actually use the Wirecast. And then the BGP, you will actually have to configure the PA autonomous system it's the PA autonomous system, okay, of neighbor. Okay, and then also each router must be knowledgeable about the PA's IP address. All right, now let's do this area 0. Okay, there's something wrong. Let's go back. These are the 3 octets, so I need to add another 4th octet, which is 0 here. Okay, now we have advertised this over here. However, on this router we didn't advertise this network. That's why we don't see any adjacents forming. So we still need to come back to this router and try to advertise that network, which is 30.30.30.0 0.0.0.3 area 0. Okay, now let's wait a second so that we will see that adjacency forming between the two, between the multi-layer switch and the router. Okay, let's give it some time. Okay, so basically it's actually taking longer than expected. Let's find out what might be the issue. This is troubleshooting steps. You will need to be able to troubleshoot some problems like this if they arise. So let's find out what's stopping this router to not form the membership with that multi-layer switch. We have said that this is the network ID and then this is the wildcard mask. Now let's run the command do show IP route. There is no OSPF, nothing. Okay, so let's run the command do show IP OSPF neighbor. Okay, okay, now let's come back to that one and see also do show IP OSPF neighbor. All right, this is the state of these two. Now let's further configure the other interface, which is this one. Do right. Now let's go to that interface as well and do the same configuration, config terminal. And then what we're trying to do is to enable the routing on the layer 3. Router OSPF 10 router ID, which is 2.2.2.3, and then let's use the network ID of that interface. In this case, let's use 30.30.30.4 0.0.0.3 area 0. Okay, do right. As you can see, there is an adjacency forming on that interface. Now if I try to ping, remember if I try, I was not able to ping from this multi-layer switch toward that interface. Now let's run a ping, do ping 20.20.20.2. What I'm expecting to see is 100% success, which means I can ping from here to there, from here to there. Now let's go into this one and see if we can be able to do that. do ping. If we can't, then we will have to see what is the reason behind it. Do ping 20.20.20.2. okay, basically according to what we see right now, we cannot be able to ping. Why? Because initially we made a mistake when we were doing the configuration. So these interfaces, they might be sharing the same IP address. So let's run some command. Do show IP interface brief, and then you will find that this interface over here, it have 30.1. What about the interface on Fastnet 0? Interface fast Ethernet 0/0 do show run. Okay, Fastnet 0, it's also sharing the same IP address. That's why we have that problem. Okay, this is how we normally troubleshoot some problems like that. So all we have to do now, we have to make one of these interfaces to have at least .2, not .1. How do I go about that? Let's maybe use this multi-layer switch as .2. In this case, I will come here and then I will select the interface gig 1/0/5, and then I will say no IP add 30.30.30.1 255.255.255.252. okay, now there is a status that says we have detached this interface from the OSPF. Alright, what if we are adding now IP add 30.30.30.2 with 255.255.255.252? Let's see what is gonna happen now. And then let's say do right. Now let's say do show IP OSPF neighbor. As you can see, we have successfully created the adjacency between the two. Now I can be able to ping the 20.20.20.2 successfully. As you can see, we have successfully pinged that gateway over there. Alright, all we have configured now, we have tried to make all of these devices to be able to communicate to each other. However, if I can try to ping something from here, for instance, if I can try to ping something from here, maybe let me just try to ping 30.30.30.1. you see, I can even not ping my own gateway that is closer to me. The reason why, it's because on these multi-layer switches we have not advertised our VLAN networks. Okay, the network IDs of our VLANs, we didn't include them. So if we leave them as they are, there is no point of this. What we are trying to say is this one can never be able to break out to the internet. However, if I can configure maybe some kind of a default routes here, I can be able to go out to the internet, right? But in this case, because we are trying to make sure that this VLAN can communicate to that VLAN and that one can communicate with that VLAN, okay, we're trying to make sure of that. So all we have to do now, we need to go back to these two multi-layer switches and advertise these network ID, all of them entirely. So I'll start by this network ID and then I'll just type in network 192.168.10.0, remember this is /27, which used 224. So if we minus 255, if we minus 224 from 255, we will have 27. Okay, we will have 27. In this case, I will use 0.0.0.27 if I'm not mistaken. So this is what we're gonna be using. Let's verify that. Calculator, 255 minus 224, it's actually 31. Sorry about that, it's actually 31. I'm thinking of that /27, it's actually 31. So we're going to be using 31, right? And then we have to include it to area 0. We don't want to specify other areas, so we will just make them as part of area 0. Okay, and then there's something that we have done wrongly here. Network 192.168.10.0. Okay, it's because we are doing this configuration on an interface level. We need to go back to router OSPF 10. Sorry about that, we need to remove that T and put R. So we need to go back to the instance, and then we can run that command again, this one. Okay, as you can see now it has worked. And then we need to include each and every other network IDs. So we're gonna move to this one, which is 32. They're using the same subnet, so I will do that, and then I will carry on. The list goes on and on and on. This is 96, if I'm not, it's 64 actually. So this is gonna be 64, and then I will come to that one, and then this is gonna be 96. Okay, let me save this. If I can try to ping now, you will notice that all of these devices, they can ping each other. But let me do these configurations here as well, because whatever I've done there, I must be able to do it on this side as well. Now let's go and say network ID, network, and then it's 192.168.10.0 0.0.0.31 area 0. I will just change this into 32, and then I will change that one to 64, and then I will change this one to 96. Do right. Okay, well, now we have successfully introduced the OSPF to each and every routers in here, and then all of these network IDs, they are also introduced to the instance that is configured on these multi-layer switches on the distribution layer level. In this case, if I can try to run the same command again, as you can see, we are getting the time to live now. I can ping any device in the network anyhow. I can ping even the 20.20.20.2 that we've been testing with all along. I can ping the DHCP server. If you recall on the last video, we couldn't be able to ping the DHCP server, so I can just ping it now, 192.168.10.100. As you can see, we can send the ping to DNS also, which is 98. Okay, let's go back to a DNS. I think there is something wrong with this DNS. Let's see what is the configuration on it. It's actually 98, and then the subnet mask is fine, and then that is fine, and let's see which interface is actually this one. Is 7. So yep, okay, this is static. Let's go to 255, 255, 255. Let's go to services. Okay, so let's run a ping from another VLAN. Let's run a ping from this VLAN. Let's ping again 30.30.30.1. I can ping it successfully, and then let's ping 20.20.20. maybe 4. I can ping, this is a network ID, we know it's a network ID. Let me ping 5. I can ping it. I can ping everything entirely on this network lab. Okay, let's ping 192.168, maybe .10, .100. I can ping it. Why 98 is not working? Okay, now it's working now. I can ping the DNS server as well. Let's say NSLookup, Wi-Fi Tech, if I'm not mistaken, Wi-Fi Tech.com. Did I say .com or it was just Wi-Fi Tech? Okay, I forgot. Okay, actually let's check. It's Wi-Fi Tech Lab. It's actually Wi-Fi Tech Lab. Let's see. As you can see, this is the NS. This is A records that we have configured in there. If I run NSLookup, I can be able to see that this is the IP address that is assigned with this name. So everything entirely on this network can be able to ping each other, okay, via the OSPF. So we were just highlighting some key concepts of the OSPF. So we will just make a lab that is based on how to actually demonstrate this Stick-Charles algorithm function. Okay, so I hope this video was so informative to you. I would be maybe doing a device security on this. Enable config. Before I close, let me just enable the device security among all of these routers. I will use something called AAA new model. Okay, I think I need to type in something here, new model, and then I will just say AAA authentication. Let's see what configuration we can use. Login default. It's AAA, which stands for authentication, authorization and accounting, authentication, login, default, group radius, a radius local. Okay, where the username is gonna be, let's just use Cisco, and then let's use the password as Cisco123. Oh shit, it should be 1, so it should be password Cisco123. Okay, do right, and then I can say password, enable password encryption, Okay, let's just say enable secret syscall 1 2 3 4 do right, and then let's run the command banner motd no unauthorized access. Okay, do right. Now if I go out as someone who's just trying to log into this device, I will be able to see that this is actually the banner motd that I've configured. It says no unauthorized access, and then it will ask for the username and password, which I created. It was syscall, and then the password was syscall 1 2 3 if I'm not mistaken. So the username is syscall, our password is syscall 1 2 3, and then now to log into the privilege config mode, I need to type in another password, which is syscall 1 2 3 4. Now I can further access my devices. Okay, and also suppose if I wanted to configure something called SSH, well, we will come to that where we'll have to configure the host name, and then we need to configure the IP domain name, and then enable CryptoKey generate RSA, and then we can use those VTY to actually configure, okay, the SSH. All right, now I hope this video was so informative to you. This is the same way I can copy and paste all of these commands to do show run. I can copy and paste this command to each and every device on this lab, all right, to secure my device so that no one will be able to access it anyhow. Okay, I'll be closing this video. Let's see each other on an upcoming video. Goodbye.